So in last class, okay, what we have seen is we are in second last unit, okay, it's about the inverter. Okay, in the inverter, there are different type of inverters are there. So we have seen a different type of inverters. So these inverters are all this whatever we have been talking till now is square wave inverter, okay, and there are so many disadvantages of this type of inverter. One most important thing in this inverter, whatever we have been talking about, is the harmonics content on is it the total harmonic distortion. Okay, this is quite important to harmonics should not be there in any way, but we that means they try to remove this harmonics in a different way, okay, but to overcome this harmonics or to overcome to achieve the voltage control, okay, mm, one most important thing in any converters, the controlling mechanism. How are you going to control this? Because all the equipment or or whatever equipment we are going to use or the component, okay, all these equipments or component that is not operating in the same voltage or frequency. So we need to control this voltage and frequency at the output. So this controlling mechanism is one of the most important factor. And in case of a power electronic devices, okay, there are ways to control this output. So to overcome all these difficulties, okay, with whatever inverters, okay, we have seen in the previous classes, okay, there are certain disadvantages. To overcome all these disadvantages, okay, all these harmonic distortions, whatever is contained on the systems, okay, this has to be removed away. Means the harmonics are unwanted signals, okay. To overcome this, okay, they came with another type of inverter which is known as the pulse width modulated inverter, which we have talked in last classes. And these pulse width modulation inverters are two types. It means three types actually. Single pulse width modulations, okay. Multi-pulse width modulations. Okay. These are the different type of modulations. Means multi-pulse or uniform pulse width modulation. The pulse widths are uniform, or a single pulse. Okay, you're just giving a pulse, single pulse to a system. So these things also we have seen in the last class. Single pulse modulation, what how does it operate, okay, and what is the pulse width modulation index? So how do we find out the with we have to compare with the reference signal with compare with the carrier signals, okay. If we try to compare these two different type of signals, then we will be able to know the modulation index of that particular system. So in case of a modulation, okay, modulation index is one of the important factor we need to see. Modulation index, we can compare modulation index are found out with this reference signals by the carrier signals, okay. Then we can get a modulation index. So modulation is a process, okay, where we are just mixing the reference signals with origin signals with the carrier signals, so we can find out the load RMS value of the output voltage. And similarly, in case of multiples with modulations, okay, that equal widths are equal. If you see the width of pulse, okay, given to the system, okay, the width of the pulse are equal in this system. So we can find out the number of pulses, okay, in one cycle, in each half cycle. So if you see a number of pulses in each half cycles are 1, 2, 3, 4 pulses are given in this. So this is a kind of a system, okay, where we're talking about equal width. If you see the width of this should be equal. I know maybe while drawing, okay, there is some changes on this width, okay, but it has to be equal. So width of the stick, if you see the multipulse with modulation in this one, it should be or uniform pulse with modulation. It's also known as uniform pulse. Pulse width should be uniform in this case.
क्या हो
Similarly, in
के या त्यो अरे उल्टी चाहिँ अरे कति थाहा रहेछ छ्या
Garchaman, can you please? Okay, so we can have a uniform width of a signal, okay. So number of pulses we can find out from this. Also we have to know the pulse width modulation of a signal, means of particular multipulse width modulations. So we can find out the modulation index in this case. Also even the RMS output voltage also we can find out. So I told you to So I'll upload this. I don't think means I think I have uploaded this one. Okay, but anyway, I have some updated in this. I've done the updation on this slide, so I'll try to upload this and try to solve these problems. Okay, in a single pulse width modulations. Okay, so output voltage of these inverters have only one pulse in each cycle. So if you see here, it has only one pulse in each cycles. Only one pulse is given in this. One pulse is given on this cycle. So this is what means the single pulse width modulation this. The width of the pulse is controlled by varying the output voltage. Means that the width of the pulse can be the what is the output voltage. So based on this, we can control the output voltage. So to achieve this single pulse width control using the full bridge inverters, okay, this is the full bridge inverter. Single pulse width modulations can be achieved with the single means full bridge inverters. So in this case, if you want to have an output voltage positive, then this S1, S2, and D1 and D2 has to be means these two has to conduct, or D1 and D2 has to be conductive if the output voltage is positive. So if the output voltage is negative, then S3 and S4 has to be conducted, or D3 and D4. So this is the sequence. Okay, we have seen similar type of diagram in a previous case also. So if the voltage is positive, then S2, S1 and S2, or D1 and D2 has to be conducted, and in case of if the voltage is negative, then S3 and S4 or D3 and D4 has to be conducted. So this is the waveform. If you see here, IG1 is the triggering of the first thyristor, means the first switch. If this is the switch, okay, this is the SCR, so silicon control rectifier in this case. So if you are triggering this, the IG1 first SCR, the first switch, then it is conducting that once it is taken. This is a single pulse. Single pulse is given from alpha to pi plus alpha. So similarly, and these two has to conduct. IG means S1 and S2 has to be conducted in this case. So conduction is to be from alpha to pi plus alpha. Then in case of switch to S2, in this S2, it means the STR2 is conducting from 0 to pi minus alpha. So similarly, in a negative voltage, output voltage is negative. In that case, then it's from pi plus alpha to 2 pi plus alpha. And in S4, it should be from 0 to alpha to pi plus alpha. So this is how it happens. So there are different mode of operations are there. When S4 and S4 and D2 is conducting, in this case, okay, when these are the different 6 mode of operations. So in first mode, when the load voltage is 0, if you see here, this is output voltage and output current. This waveform is output voltage and output current. This dotted line represents the current, and this is the voltage. Now, when the voltage is 0, in the first mode, S4 and D2 is conducting in this case. So in S4 and D2 is conducting, load current is also negative. If you see that this is the dotted line are the current. So current is negative, minus. So its current is negative. In this case, voltage is 0. This voltage is equals to 0. Now, this is the case when S4 and D2 is conducting. S4 and D2 is conducting. So this operation is in a freewheeling mode. This when S4 and D2 is conducting, then it's in a free operation is in a freewheeling mode. Similarly, in mode 2 operation, the load voltage is positive. This is the mode 2 operation when D1 and D2 is conducting. In this case, load voltage is positive, but the current is still negative. So voltage is positive, load voltage is positive, current is still negative. When D1 and D2 is conducting, then it's a regeneration mode. Similarly, mode 3 load voltage is also positive. In this case, this when S1 and S2 is conducting, S1 and S2 is conducting, load voltage is positive. The current is also positive. You see here, in this case, when S1 and S2 is conducting, voltage is also positive, current is also positive. Now, in this case, S1 and S2 is the inversion mode. So this is our inversion mode, means that it's an inverting mode. So similarly, in mode 4, this is a mode 4, so where voltage is equals to 0. There is no voltage. Voltage is 0, current is positive in this case, when S1 and D3 is conducting. So S1 and D3 is conducting, down this is also a freewheeling mode. The load voltage is equals to 0. So similarly in mode 4 is load voltage is negative. This is a when D3 and D4 is conducting, the voltage is negative. Now when this is where D3 voltage is negative, but the load current is positive. In this case, load current is positive. In this case, D3 and D4 is conducting. Okay, voltage is negative, but still the current is positive in this case. So it's a freewheeling mode, and again in mode 5, the load voltage is positive. Load voltage 1, 2, 3, 4, 5. This is 5. Then next 6. In next 6 is the load voltage is negative when S4 and D2 is conducting. So similarly, S4 and D2 is conducting, then the load voltage is also negative, current is also negative. In this case, S3, S4. So what is happening is that is a inversion mode. So similarly, it will keep on continuing. It means like there will be a continuation again. Then it will be mode 1, mode 2, mode 3, mode 4. There are 6 modes of operation in this single pulse width modulations. So this is how the pulse width modulations work. Now the other topic is the waveform control using filters. So we can control the waveform. Waveform can be controlled using the filters. Means that we need to remove the unwanted signals. Okay, the filters are connected at the inverter. Some harmonics can be eliminated. Just to remove the harmonics, from a system, then we connect the filters, and the waveform can be improved. We have seen in case of a rectifier. I know you have done the experiment even in analog electronics. Okay, that when you do the rectifier circuit, okay, the input is AC and output is DC, but you do not get a pure DC, but it's a pulsating wave. That's why you use a filter to remove the unwanted signal from this. Means we have a pure DC at the output. So there are different way of removing that, means improving the systems. Okay, the waveforms can be improved. So the one way is using the filters. The filters may be L and C filters, or it can be a resonant filters. So these two filters can be used. So in case of a LC filters, okay, L and C filters, inductance and capacitance filters, the reactance of the inductance increases with the frequency. So reactance of inductance will increase. It will increase if in case of inductance, reactance will increase with the increase in the frequency. And the effect of series inductance is to attenuate the higher frequency. So in case of series inductance, it will attenuate the higher frequency. So reactance now it's just opposite. Okay, reactance of the capacitors is inversely proportional to the frequency. In case of the inductance, it increases with the frequency, but in case reactance of the capacitance is inversely proportional to the frequency. So these capacitors, okay, some capacitors will allow the higher frequency to pass. That's why these two combinations are quite good. That's why they is known as the L and C filter. So these two filters, the shunt capacitors allows the higher frequency to pass through. Just wait second. Okay, I think there's a problem. Hello? And these two combinations, okay, L and C combinations are used to like reactance of the capacitors. It is inversely proportional to the frequency. In case of inductance, increases with the frequency. So these capacitors will allow the higher frequency to pass through. So both the series inductors and the shunt capacitors are used in combined effect of inductance and capacitance. It will eliminate the higher order frequencies to the considerable extent. So it will eliminate the combinations of L and C filter will eliminate the higher order frequencies to certain extent. Not all the harmonics, but to a certain extent it can eliminate the harmonics. So this is the L and C filters. So where the combination of L and C are used. The lower one is the first one is the single sections. L and C LNC is used in case of this is the cascading section. So we can use in a cascading form also. The filters LNC filter can be formed not a single LNC filter, but we can use more than one LNC filters. So similarly, in case of resonant filters, it has a series resonant circuit. It also contains LNC, and the parallel resonant circuits also it's consisting of another LNC. So it is a resonance filters. So resonant frequency of both the series and shunt arms is equal to the output frequency of the both the series and shunt arms, it's equal to the output frequency of the inverters. So the series arms will present zero impedance to the fundamental frequency. So please remember that the series arm will present a zero impedance to the fundamental frequency, and it will also increase the impedance to the higher frequency. So combination of both the series and shunt resonance circuit will try to complement each other. That's why series and shunt, it will try to complement each other's in resonant frequency. So this is the resonant frequency. So you don't have to go in detail of the means like detail on the filters, okay, just to have to eliminate the means like higher order harmonics, okay, we use the filters are also used. And if you see, we have been talking that there are harmonics and total harmonic distortions are there, means that we are converting the DC into AC, we are inverting. This is an inverter, we are talking about the inverter, so there will be unwanted harmonics will be contained in the system. So to eliminate all these harmonics, okay, people try to use different techniques to eliminate these harmonics, to remove the unwanted signal. So it's quite important, okay, in case of high voltage DC transmission systems, okay, these systems can be used in a different form. Sweet. Then just to eliminate all these unwanted signals can be eliminated by using pulse width modulation. So most of the case, okay, they nowadays, okay, they use the PWM pulse width modulation techniques just to remove the unwanted signals. So with this, okay, this is end of the second last unit, okay. You can, all these notes are I have taken out from this books, okay. You can refer this if you want to go in detail. PS Beamer, I think you have a soft copy. Receipt also you have a soft copy, okay. All these notes, whatever notes are taken out is from this textbooks. Reference are from this textbook. So please go through all this in detail, okay, so that you know about that inverters, okay, how do you use, because these things I feel that it's quite important for you. This is to understand, okay, when you talk about the power systems, when you talk about all the power system related subject, okay, you should have a fundamental background of power electronics, because if you do not understand what is power electronics, then it will be difficult for you to understand all these controlling mechanisms, okay, in other modules. And power system application is another module, like a prerequisite to the power electronics. Now, to understand this power electronics application, okay, all these fax devices, okay, these fax devices are all the power electronic devices actually. Flexible XT transmission system, okay, fax, all these SB static bar compensator, or all these different types of technique. These are something new, okay, but ultimately, if you see, it's just they use the combination of series and shunt, or either in series or shunt of all these power electronic devices are used. So if you have a good background of the power electronics, then it will be easier for you to understand all those things in the power systems, to analyze the things. So it will, even in power system operation control in a third year, okay, those who are in third year, I think you must be studying this. So it is quite important to understand the power electronic devices, so that it will be easier for you to understand the modules in higher semesters. So please go through the textbook, especially if you want to go through in detail, okay, like Rashid is also one of the good textbooks, and PS Bimra, usually I refer these two textbooks, PS Bimra and Rashid. I find these two textbooks are, of course, these textbooks are there. Almost all the textbooks are similar, but it depends on how do you take in the means if you to make yourself understand the things, okay, that I have been studying these two textbooks, so I feel comfortable going through these two textbooks. So you can go through any of the textbooks so that you try to solve all the problems related to the inverters and whatever we have completed. Now that we just have one unit, that's last unit. Okay. So last unit is the AC regulators. Okay. AC regulators, it will hardly take around 5 to 6 classes, and after that we'll complete our syllabus. So if you have to return back to the college by June, then I think straight away you can solve few problems. If you get time, then you have to do the practicals. Practicals you have not started yet, so directly do the problems. And if whatever doubts are there, okay, so we'll try to clarify. Okay, we'll try to clarify each other. So if there are doubts, so we'll do some clarification if you happen to turn back to the college. Okay, so please prepare now itself. So there are certain indications from the government that government might reopen the colleges and schools, but we don't know when they're going to open. But make yourself, like, prepare yourself so that you don't have to face difficulty at the last minute. Wait, okay. Wait, okay, I'm taking the attendance. Okay, I'll stop here and we'll continue in the next class of the last unit. So if you have any doubt, or we'll talk in the next class. Okay, I'll stop here.